Welcome everyone to 6th grade math with Carnegie Learning. This is the middle school math solutions book and we are working in module 1. This is our very first video with this course. This first page that I'm showing you sets up how the first module is laid out. Within this module there's 3 different topics. We're starting with topic 1, which has factors and multiples as our first topic within the module. And then as you can see, there are 5 different lessons within this module. And then the purple are the Mathia workspaces that align with it. You can find all of this on page 1 of the course textbook, whether you're looking at the physical book or looking at the e-text online. Okay, well, let's get started. We're starting with lesson 1, taking apart numbers and shapes, writing equivalent expressions using the distributive property. So if we flip this over, there's just this little getting ready for module 1, and we're not going to do that right now together. We're going to move on to the actual lesson. Okay, so within this lesson, we have some key terms. They are numeric expression, equation, distributive property of multiplication over addition. The title is taking apart numbers and shapes. We are going to be writing equivalent expressions using the distributive property. Our learning goals: write, read, and evaluate equivalent numeric expressions. Identify the adjacent sides of a rectangle as factors of the area value. Identify parts of an expression such as the product and the factors. Write equivalent numeric expressions for the area of a rectangle by decomposing one side length into the sum of 2 or more numbers. And apply the distributive property to rewrite the product of 2 factors. So every lesson starts with a quick little review. Says you know how to operate with numbers using different strategies. Take apart numbers before you operate. Taking apart numbers before you operate can highlight important information or make calculations easier. We're going to be doing that. Says how can you use these strategies to express number sentences in different ways. So that gives us our purpose on what we're doing here. So if we're going to calculate the area of each rectangle, we can certainly just do 15 times 6. If we did that, you'll see me for the multiplication symbol use either a star or just a dot. Now that you're in 6th grade, we're no longer going to use the X because that will be representing a variable in later lessons. 6 times 5 is 30, so we put down a 0 and we carry the 3. 6 times 1 is 6 plus 3 is 90. So we have 90 inches squared. So if you remember, area is length times width. So that's what we did, the length times the width. And then for the second one, show your work here, we have 12 times 9. So area equals length times width. When 2 letters sit side by side, it means the same as if we wrote it with an L times a W, length times width. 2 side by side still means multiply. So area equals 12 times 9. There, I just showed you how to use the little dot. And if I wrote it over here as such, I could do 9 times 2 is 18. Put an 8, carry a 1. 9 times 1 is 9, plus 1 is 10. So my area is 108 inches squared. I'm going to try to adjust this lighting here a little bit. It's really quite in my eyes, and see if we can get it better on the paper. Okay, turning the page. Getting started. It says break it down to build it up. So our getting started always has this airplane. The top of the page always shows us where we're at. So we are in topic 1 of factors and multiples, lesson 1. We're on the getting started activity. Cal is installing a rectangular walkway up to her house. The width of the walkway is 5 feet and the length is 27 feet. She needs to calculate the area of the walkway to determine the amount of materials needed to build it. Mark and label 2 different ways you could divide an area model to determine the area of the walkway. So 2 different ways we have to figure out the area. We know that it has a width of 5 feet and a length of 27. So we know this is 5, and this whole thing from here to here is 27. But they want us to divide it up so that we have a bit of an area model. So when I see 27, I immediately think 7 and 20. Another way we could do it, 5 is still the width. We know we have 27 from here to here. And maybe you're thinking about 10. Oh, that's not going to be drawn correctly. Let's scoot that over. Maybe 10, 10, and 7. 10, 20, 27. Number 2 says determine the area of each subdivided parts of your models. So I'm just going to do the work right up in here for number 2. So the area of each subdivided, remember area is length times width, L times W, either way you want to write it. So the length is 7, the width is 5. 7 times 5, so this would be 35. 20 times 5, well, 2 times 5 is 10. Put a 0 on, we have 100. And then we would just need to add those together to get a total area of 135 square feet, feet squared, either way. For the second one, we have 5 times 10, or 10 times 5, length times width. So this part would be 50. It repeats here. And then 7 times 5 is 35. Adding them all together, we have 50 plus 50 plus 35. We still get the same 135 feet. And you can put a little 2 up in the air, exponent, also meaning squared. That then answers our question number 3 as well. Okay, we're going to move right along. Activity 1. Connecting area models and the distributive property. The numeric expression of 5 times 27 represents the area of the walkway from the getting started. A numeric expression is a mathematical phrase that contains numbers and operations. So I want you to underline that or highlight it. If you have a highlighter, put a star by it. The equation 5 times 7 equals 135 shows that the expression 5 times 27 is equal to the expression 135. An equation is a mathematical sentence that uses an equal sign to show that 2 expressions are the same as one another. Our habits of mind: look for and make use of structure, look for and express regularity and repeated reasoning. And our think about says what are other ways you could take apart one of the factors and write a corresponding equation? What would the equation look like if you divided the model into more than 2 regions? And we had already done that. But reflect on the different ways you can rewrite the product of 5 and 27. Select one of your area models to complete the example. How did you take apart the side length of 27? Well, on the first one here, we did 7 and 20. So we did 7 plus 20. What are the factors of each of the smaller? So we had to do 5 times 7, and which gives us our plus sign, 5 times 20. When we multiplied the 7 and the 5, we got 35, and 20 times 5, we got 100. That's what goes here. So this 5 times 7, 35 is represented right here. And then this 5 times 20 is what goes right here as 100. Now we're going to add those together to get the 135. You just use the distributive property of multiplication over addition. highlight this, star it. The distributive property of multiplication over addition states that for any numbers, A, B, and C, the equation A, and we read this, times the quantity of B plus C equals A times B plus A times C is true. So let's just put the numbers in that we had here. Otherwise, this sounds kind of confusing to you guys. So we have, if A is 5 and B is the 7, because that's what we had here. Wait for that to focus. So if A is 5 and B is 7, C is 20, we have this. And then we're saying it equals A times B. Remember I said when two letters sit next to each other side by side, it means multiply. So A times B, and we're going to add that to A times C, which is 20. So we're doing 5 times 7, then 5 times 20. Okay, so explain the distributive property using the area model shown. So with this area model, the width 5 is multiplied by each of the smaller side lengths. Let's make this a new sentence. They, how about these products are then added together. Okay, if you need to pause to copy that down, please do. I'm going to keep moving to keep the video not quite so long. An example of the distributive property. So we have 4 times the quantity of 2 plus 15. So this arrow says we're doing 4 times 2, which they're showing right here. And then this arrow shows 4 times 15, which we're doing right here. Notice we had a plus sign here, and the plus sign is in between those. You can also use grouping symbols to show that you need to multiply each set of factors before you add them, which is what the parentheses are. So we could do this. So to show we're doing 4 times 2 and 4 times 15, then adding them together. So the way you read this, you can read this expression written like this in different ways. For example, you could say 4 times the quantity of 2 plus 15. 4 times the sum of 2 and 15. Or the product of 4 and the sum of 2 and 15. You can describe this expression, 4 times the quantity of 2 plus 15, as a product of two factors. The quantity 2 plus 15 is both a single factor and the sum of two terms. So basically what they're saying is this works as one number. We just have it broken down into two smaller. 2 plus 15 is literally the same as 17. Fill in the missing addend in each box that makes the equation true. So we know we're going to do 7 times something and get this first number, because we do 7 times 10 and get this second number right here. 7 times 10 is 70. So 7 times what will get us to 21? Well, that's 3. 3 times the quantity of something plus 15 equals 36 plus 45. Well, they're giving us the 3 times 15, and we know that's 45. So we need to say 3 times what gets us to 36? Right, it's 12. 3 times 12 is 36. 8 times 2 gives us a 16, plus 8 times something to give us 56. Correct, 7. 5 times the quantity of 6 plus some number equals 30 plus 45. Well, we know 5 times 6 gives us the 30. So 5 times what gets us to 45? And that is 9. Number 4, rewrite one of the factors as the sum of two terms in each expression and then use the distributive property to verify each product. So they're giving us 4 times 7 equals 68. Well, what if I wanted to do 4 times 7 plus 10 for the 17? Do we still get 68? 4 times 7 gives me 28, plus 4 times 10 gives me 40. And when I add those together, I do in fact get 68. 9 times 34, so maybe 9 times 4 plus 30. So 9 times 4 is 36, plus 9 times 30. Well, 9 times 3 is 27. Instead of just doing 9 times 3, we're doing 10 times more than that because 30 is 10 times more than 3. So we're going to make this 10 times more and put a 0 on the end. Now, when we add those, we have 270 plus 36. If you can't see it going this way, please go ahead and write it vertically. So we have 0 plus 6 is 6, 7 plus 3 is 10, and 1 plus 2 is 3, 306. It does, in fact, work. Last one, 3 times, and we could put the bigger number first, 20 plus 9. So 3 times 20 is 60. 3 times 9 is 27. We add those together and get 87. Again, pause if you need to. Identify each statement as true or false. If the statement is false, show how you could make it true. So it says 3 times the quantity of 2 plus 4 equals 3 times 2 plus 4. So 3 times 2, I see that right here, but I don't see 3 times 4. It just has a 4, so that is false. So to make it true, it would have to say 3 times 2 plus, you got it, 3 times 4. 6 times the quantity of 10 plus 5. So here's the 6 times 10. 6 times 5. We were adding here, adding here. That one is true. 7 times the quantity of 20 plus 8. So we have 7 times 20. Oh, but here we have 7 plus 20. And we should have 7 times 8, and we just have 8 times 8. So this one's definitely false. So we should have done 7 times 20 and added that to 7 times 8. 4 times the quantity of 5 plus 10 equals 20 plus 10. Let's see, what is 4 times 5? 20. What is 4 times 10? 40. So this one is not correct. So we could say 4 times the quantity of 5 plus 10 equals 20 plus 40. And lastly, 2 times the quantity of 6 plus 11 equals 12 plus 22. 6 times 2, 12. 6 times 11, 22. So that one is true. Last part, talk the talk, is the last part in each lesson before the assignment page. So we're still topic 1, lesson 1. We've done the getting started. We've done activity 1. Now we're up to talk the talk. The floor is yours. You can apply the distributive property to solve real world problems. Consider the situation. Tyler's setting up the gym floor for an after school program. He wants to include a rectangular area for playing volleyball and another for dodgeball. He also wants to have an area for kids who like to play board games or just sit and read. The gym is 50 feet by 84 feet or 4,200 square feet. Create a diagram to show how you would divide up the gym floor. Represent your diagram using the distributive property and write an explanation for the areas assigned to each activity. So we know it's 50 by 84. So 50, maybe 84 might be here. And this is the 50. And this whole side here is 84 from one end all the way to the other. But then we need to divide it up. For kids playing volleyball is one area. Dodgeball is a second area. And then board games or sit and read. So we need to take 84 and divide it up into 3 different sets of numbers, 3 different groups of numbers. So when I think about this, I'm guessing the kids that are going to play the board games or just sit and read probably don't need as much space as the volleyball and the dodgeball. So if we took this far end of the gym and we just did from the 84, if we just did 4, because 50 times 4, this part here would be 50 times 4, which would be 200. This would be 200 square feet. That's probably plenty of room for reading and board games. So then we would have 80 feet left for here. And I think volleyball and dodgeball would take up about the same amount of room. So I might just split it in half. It doesn't look like it's in half. Maybe over here, your drawing does not need to be perfect. This would be 40 and this would be 40. So this would be 50 times 40, another 50 times 40, which is 2,000, and this is 2,000, and we would add them all together. So before we write it out like this, what we would have seen is 50 times 40 plus 40 plus 4. So we have 50 times 40 plus 50 times 40 plus 50 times 4. The addition signs stay, and then if we add all the way across, we have 2,000, 4,000, 4,200 square feet, which is what the problem originally stated. Okay, and from there, you are going to move on to your lesson 1 assignment, which is questions 1 through 6. They're pretty much exactly what we just did. If you want to try the stretch, you can. It is optional as it's stated here. This one, evaluate each expression using the distributive property. So you're just going to do 6 times 12 and then 6 times 24 and add those together. The same will be true here. You'll have 10 plus. You're going to distribute the 4 times the 2 and also the 4 times 20. I'm going to write this one out. We'll see how many kids are following along with this video. 4 times 2 is 8. 4 times 20 is 80. So if you add that all together, you're going to get 98. Okay, so 1 through 6 is your homework, and we'll see you on the next video for lesson 2.